All right, so here we go. 5-4D, we're doing some boxes. We're going to do 2 boxes and a cylinder today. So number 1, given a 20 by 25 inch piece of material, what dimensions of an open rectangular box will maximize the volume? So now it's volume instead of area and perimeter. Open. Okay, so this is what you're given. You're given a piece of paper that is a 20 by 25. Okay, so figure not really drawn to scale. This looks more like a box, but or a square. So this is 20 by 25. And what we're going to do is we're going to make that into a box. But the box isn't going to have a top. Okay, it's going to be topless. All right, so, sorry. My bad. All right, anyways. So what we're going to do is you want to, have you ever made a box from a piece of paper? Yeah. Yeah? You want to cut off the corners. Okay? So we're going to call those corners, we're going to call them X. And it's going to be a square. What you do is you take a piece of paper like this and you cut the corners, and then you can fold it up and it turns into a box. Can you imagine that? Yeah. Do you want me to do that real quick for you? No. Okay. So when you do that and you fold it up, what happens is it looks like this. So there's your box right there. Sure, you can't. Come on, you guys all took geometry like 40 years ago.
I hated geometry.
Me too. There you go. That's pretty good. You like geometry? Really? Oh, I never liked geometry.
I didn't either.
Okay, now once you have cut those sides off of this, what happens is it makes the box smaller, but you have to because you have to fold it up to make the box. So then this is what the dimensions of the box look like. This would be 20 minus 2x, okay? Because you ended up taking an x off of each side, and then the length here is 20 minus 2x. And then what would the width be then?
25
Yeah, 25 minus 2x. And we know that a box has a volume is length times width times height. What's the height of this box? It's x. Okay? When you fold it up, that's going to be the height, that x that you cut off. Okay. Yes, and so now the volume is x times 20 minus 2x times 25 minus 2x. And we're going to maximize the volume of this thing, so we have to take the derivative and set it equal to 0. But before we do that, we're going to FOIL it out. Yeah, so I would leave the x out front for now, or you can distribute it in. I would just distribute at the end. But 20 times 25 is 500. Outside gives me negative 40x. Inside is negative 50x. My last term would be 4x squared. So the volume would be 500x minus 90x squared plus 4x cubed. Everybody okay with that? Yeah? Yep. So let's take the derivative of the volume. So we get 500, it's a cubic, so we're going to end up with a quadratic when we take the derivative. But some of you guys have that fancy program. Yeah, if you don't, you might want it. You can use it. Plus, it's not cheating, plus 12x squared. So set that equal to 0. Does anyone need that program? Because you guys can link it to each other if you want. Yeah. Do you know how?
Yeah, but you can't use that. How would you delete that?
So then you solve this by quadratic formula, whatever you want to do, on your calculator. I like that program. And so you get about 3.68. And then you also get another x, but as you know, when you plug that back in, it doesn't work. Whoa, look how small that is. All right. You didn't get 3.68?
I did. When you plug it back into where?
Yeah, so when you plug
Did
it...
you put it in the right order?
I took the derivative wrong.
Oh, you did?
I didn't put it in the order from x squared to x.
My derivative was wrong.
So then the base of it is 20 minus 2x. If you use the other x, because there's two of them, that x will be too big. You'll get 20 minus 2 times that x, which will give you a negative base. You can't have a negative base of your, yeah. So you plug 3.68 back in, and so the base would be 20 minus 2 times 3.68. Yeah? 12.64 inches. And then the height is x, so 3.68 inches. And then the length is 25 minus 2 times 3.68, which is 17.64. So that's the dimensions. It says, what? There's 3. So there's length, or whatever you want to call it, length, width, and height. And did it ask you for the volume or no?
Does it matter what order you put in?
Nope, not at all. Okay? Nope, it says what dimensions of an open rectangular box will maximize the volume. Those are the dimensions. Okay? Pretty good. You really just need to know what x is. If you know what x is, then you can just cut 3.68 off of each corner, and that'll make the right box for you.
You don't have to put it in any particular order? with
No.
the dimensions?
As long as I can see all 3 of them, it's fine. It's pretty obvious which ones are which. Okay, here we go. Number 2. A square bottom box has a volume of 252 cubic feet. The bottom of the box is made out of cheap cardboard, costing $2 a square foot. The fancy top of the box costs $5 per square foot, and the sides cost a mere $3 per square foot. Find the dimensions of the box to minimize the cost, and what is the cost of this box that you're making? Okay, let's draw a picture. Here we go, geometry friends. Right? Draw a box. This is how I always draw boxes. You draw a square first, and then you draw your slanted lines parallel to each other. You draw one across, and then one straight down, one over here. I learned that in Drawing 101 for math teachers. Just kidding. Thank you, Molly, for laughing at that. But people are going to think I was serious. Like when I juggle and my kids are like, wow, I'm like, yeah, I learned that in juggling school, and they think I'm serious. Okay. Now, this is a square bottom. It's a square bottom box. So it's an X by X on the bottom. And then the side, the height is not X necessarily, it's Y. You don't know what it is. Okay? Because it's a square bottom, so the bottom is X by X. And then, oh. Thanks, Kevin.
I was waiting to.
Got him. Got him. All right. So, no. He said Y, yeah. So the volume is 252 cubic feet. Do you see that feet cubed? That's volume. So the volume of this box is, X squared Y. So X squared Y equals 252. That's the volume. That's the equation that we have. We don't do anything. Well, we're going to do something with it in just a minute. Now, we're trying to minimize the cost. So let's find out what the cost equation is. Be careful, because I wasn't here to teach you that other one, but you have to put the cost into the function as you go. So let's see. The bottom is made of cheap cardboard, $2 per square foot.
Square?
Yes, exactly. So the bottom would be 2x squared. It's the area of the bottom times how much the cost of it. Plus, the top of this thing is $5 per square foot. So the top would cost you 5x squared. Okay, and then the sides. How many sides are there? There's 4 sides. Okay, and the sides are all what?
3.
Okay, so 3 times xy. But there's 4 of them, so times 4 of them.
So we just do 12.
Yeah. Okay, that's the cost. Okay, so it's xy because the side, like this side right here, has x as its bottom and y as its top. So it has an area, of xy. And all the sides are the same. They're all xy because it's a square bottom.
The leading coefficient is always the price tag.
Yeah, well, the cost is the area of whatever you're doing times the cost of it, so times 2. So let's go ahead and let's clean this up. So my cost would be, I have 7x squared plus 12xy. Okay, and I have to minimize the cost. I'm going to need to take the derivative of c here, but it's in 2 variables, and I haven't used the volume formula yet. So let's go back up to volume and let's solve for y. Definitely. Not going to fall for that twice in one day. I'll fall for it next week, though. So y equals 252 over x squared. And then we'll go and we'll substitute it into our cost. Here we go. Cost equals 7x squared plus 12x times 252 over x squared. And you really want to simplify any of your formulas before taking the derivative of them. It's really helpful. So this is 7x squared. These x's here will reduce one of them, giving you plus 12 times 252. I worked that out. It's 3,024 over x. Okay, so now it's beautiful. It's all in terms of x. It's all simplified out. Now we have to take the derivative of it. So here we go. You ready for the derivative? Yeah, we will. So c prime is equal to 14x. And then this, this is, if you wanted to rewrite this as 3,024 x to the negative 1, that'll probably help you a lot there. So bring the 1 down, minus 3,024 over x squared. Are you getting used to taking the derivative of that? Yeah, we've seen that quite a few times, especially when you're minimizing something. Okay, so we'll take that derivative and we'll set it equal to 0 and solve. So 14x equals 3,024 over x squared. Are you running out of room?
No.
Good. All right, we'll cross multiply. And you get 14x cubed equals 3,024. Divide both sides by 14. Anyone do it yet?
Yeah, x is 6. Oh, yeah, 16.
Yeah, x cubed is 216, which is a perfect cube. X is 6. I love it when they work out so pretty. All right, now let's go back to the original question of what they're asking. So if x is 6, I need to find the dimensions and what is the cost. Okay, so let's see. The box would be a 6 feet. Oh, this is a big box. 6 feet by 6 feet by, and what's y going to be? 8? Where'd you figure that out?
7?
Let's see.
How did you get 8?
Well, y is 252 divided by x squared.
256.
252 divided by 36 is 7.
Yeah, well, 7. Yeah, I'd actually put 256.
Ah, by 7 feet. Is this a coffin? Did we just make a coffin? It's a really big coffin, though, for a fatty. Sorry, it's terrible. Okay. Anyways, and then what would the cost be? Cost, you can go to a variety of places to find the cost. I would probably go to this one right here. You don't want to go to any of the C primes for cost. Okay, you want to go to a cost function. So cost would be 7 times 6 squared plus 3,024 divided by 6. How much is this going to be?
$756.
Wow, what are you making? 3,024 divided by 6. Oh, I got $756. Is that wrong?
I just said.
Oh, oopsie whoopers. All right, 756. There you go. 756 bucks to make this box. Now, why would you want a cheap cardboard bottom when it's this huge box and make a real fancy top?
And all out of cardboard
Cardboard.
for $756.
That was great, you guys. That was so fun. Did you like it? You like it? Yeah.
Why did you even bother writing 6 feet by 6 feet by 7?
Oh, because it asked for find the dimensions and then what is the cost. Yeah. A lot of times these questions, they'll ask you 2 parts, so you need to be really careful. I usually just write a whole bunch of answers down, all the stuff, and then I'm
everything.
yeah, and then I'm solid. Okay. All right, we got one more. One more to go. Solid. Here we go. Okay. Cylinders.
Why is it on a whole page?
Is this, I don't know. Does yours just say cylinders on it?
No, it's a cylinder slash poster.
Poster. Okay, mine says cylinders / variations on rectangles, so that's not right. Yeah.
And then it won't even be
That's
noticed.
what I do with my notes when I wrote, puts an extra line somewhere.
Oh, you do that?
Cover it in white.
Is this all the same though? This is the same question?
Yeah, your
1
supervisor
liter?
asked you to design,
Okay. Perfect. All right, your supervisor asked you to design an aluminum can that will hold 1 liter, and then make sure you give it to Miss Price so she can recycle it when you're done. All right,
That's a big can.
it is.
That's not that big.
1 liter?
Coke is like 2
But a
liters.
can?
A can of 1 liter?
A can?
All right, here we go. What dimensions will use the least amount of aluminum? Okay,
Spaghetti sauce.
so we're gonna do 2 things here. First of all, it's gonna hold 1 liter, and you know, 1 liter equals 1,000 cubic centimeters.
Would you tell us that?
Yeah. So we want to find out centimeters here. So, do you guys know anything about cylinders? Do you know the volume of a cylinder?
3/4. Wait, 2/3.
Nope.
It's a fraction, isn't it?
No.
Pi something.
Yeah. Okay. You know, volume.
Molly.
Volume is simply area. It's base times height is volume. It's the area of the base times the height. Okay. So what's the area of one of these bases? What's the area if we label?
Squared.
It's pi r squared.
2 pi squared.
Just pi r squared
Top and bottom.
for volume,
Oh, yeah.
and then times the height, which we'll call h.
That's close.
Pretty close. It's been a long time for you guys because
Wait, which is the one where it's like 3/4 or something?
Yeah,
that's sphere. No, cone. Yeah.
Same.
you're close enough.
Okay. All right. So let's label these things here. You have h is height, and then you have to the center of your cylinder up top. That's r for radius. So volume is pi r squared h. Now the surface area. The surface area of this sphere is going to be the area of the bottom plus the area of the top. Those should be the same size. And then plus the area of that whole can, and when you unravel it, it turns out to be a rectangle. Okay, so let's talk about what's the area of the top circle. What's the formula for that? That would be pi r squared. The area of the bottom circle, or whatever, they're both the same, they're pi r squared. And then the area of this rectangle, when you unravel the cylinder, this is h is the height there. And when you unravel it, what's that? That's the circumference of the circle, which is 2 pi r. Can you picture that? So you have your, it's all wrapped up like this. Here's the circumference of the circle. When you unwrap it, it's the height times the circumference. Yeah. Okay, so then that means that the surface area would be 2 pi r squared plus 2 pi r h. Surface area of a cylinder. I'm going to run out of room. No, I have stuff on here. I don't know why.
You could just cover it in white.
Yeah, cover in white. And then
I don't know how. Oh, okay. Yeah. Good idea. That's what you were talking about earlier. I didn't understand what you were talking about, so I just ignored it. Okay. That's what I do when I don't understand something. I just ignore it. So let's go ahead. We know the volume is 1,000 cubic centimeters. So let's plug in 1,000 for the volume. So 1,000 equals pi r squared h. What we're trying to do is we're trying to minimize the surface area. So I need to take the derivative of surface area.
how do we know it has to be in
Because this is liters and I need dimensions, I need height and radius, so I need centimeters.
Okay.
So this is 1,000 equals pi r squared h. I'm trying to take the derivative of surface area, but surface area has r and h in it. Let's take this and solve for h, okay?
How did you get pi r squared?
That was from the volume. Volume equals pi r squared h. So volume is the base times the height. So the area of the base is pi r squared times the height of it. That gives you volume. All right, so let's solve for h. h equals pi r squared over 1,000. But I don't have a white.
Wait,
That's wrong.
No, other way around, sorry. I don't have a white though.
Probably,
You don't have white?
I don't think so.
You need to get-
Sorry about that. It's 1,000 over pi r squared. Thank you for listening and paying attention. Appreciate that. No, I don't. I have yellow. Good enough. Okay, so here we go. Now, let's take that and we're going to substitute that in for h right there. Okay, so the surface area is equal to 2 pi r squared plus 2 pi r times 1,000 over pi r squared. Is everybody okay with that? Okay.
one of them cancel out.
Yeah. So pi's reduce,
R.
r reduces with one of them. So you get the surface area is 2 pi r squared plus 2,000 over r. Isn't it funny how whenever we're minimizing something, we always get that, like over x, over r, whatever. Okay, so now we're ready. We've done all the geometry and algebra work. Now we're ready to take the derivative. So let's take the derivative of surface area. I probably should have just labeled it as one variable, as s, but whatever. So the surface area is equal to 4 pi r. This is r to the negative 1, so minus 2,000, perfect, over r squared. Set it equal to 0 and solve. So 4 pi r equals 2,000 over r squared. These are never going to turn out nice because pi is involved. They're not going to come out to 4 or 5 or something cool. This one actually turns out to be kind of cool. I'll show you why. R squared, you get r cubed. So 4 pi r cubed equals 2,000. Divide by 4 pi. Okay, if you're going to put that whole thing in your calculator, make sure you divide by parentheses 4 pi. And then take the cube root. So let's see if you got it. Let's see if I can get it. Math, you know where cube root is?
Math 4.
It's under math number 4. I got 5.42. Okay, so the radius is 5.42. Now, this is kind of funny. What is the question asking for? What dimensions? So we have to find the height now. The height of this height is 1,000 over pi r squared. So 1,000 divided by, I'm going to do parentheses, pi times my answer squared. That way I'm not rounding, you know, a lot. And then I get 10.84. Why did I write R?
Wait, how are you getting?
I got 10.84 even though I wrote
Oh, you did?
Yes, even though I wrote it yes.
Oh, cool.
10.35.
Okay.
Is it centimeters?
Ugh. Sorry. It is. It's centimeters. I could have just turned that into a centimeter. Now let's look at this really quickly. Do you see how the height is twice as much as the radius?
Is it always?
Yeah, it happens that way a lot. So the radius, the diameter is 10.84 and the height is 10.84. It looks like this is like you just made like a tuna can or something, huh? You know what I mean? Like the height
Oh, yeah.
is the same as here is going to be the same as here. It's like a square cylinder. That's really bad. Okay. Anyways, that would be your answer.